All right, let's look at the latex allergy in healthcare workers. So there was a study done in March 2004 of latex allergy in healthcare workers. And we had an H naught. Okay, so we're writing down number 1, mu H naught, number 2, H sub A. So mu is the mean number of latex gloves used per week by all hospital employees. So we say mean number gloves used per week at hospital. And I think it's per employee because it's not a very high number. And then I'm hoping it's per employee. And then we have mu equals 20, so that's going to go here. Mu equals 20. That's our H naught. And then H sub A, or our alternate hypothesis, that's going to be mu is less than 20. Now I think most of you have been noticing when you have an equals a number, that's almost always going to be your null hypothesis, and then either less than, greater than, or not equal for your alternate hypothesis. Okay, so then step 3, we're going to have, we have some data. We know that we're going to have left tail, our n is sufficiently large, so we're going to say a z statistic. And that's going to be x bar minus mu naught over s over square root of n. And so we've identified our statistic, and now let's look at our alpha. Did they give us an alpha? They gave us one late in the game, but we can go ahead and put it in here. So alpha will be 0.01, and that'll make our rejection region. Sometimes they don't give you an alpha and they just want you to find the p-value, and that's perfectly reasonable because that's what a lot of studies do. And that's why we spent so much time trying to understand what that p-value means, because we want to be able to go with just a p-value and not have been given a reject or fail to reject, because that's going to be our job as a reader. Okay, so here we go. Here's our picture. And based on our less than 20, we're going to have a left tail, and we want this area to the left to be alpha equals 0.01, because that's our alpha, and we're not having to split it between two different tails. It's just a single tail, so it gets all of that area. So 0.01 means that in the middle, on the left-hand side, we have a 0.49. A 0.49, and when we look that up in the middle of the chart, because it's an area, 0.49 is going to be 2.33. So negative 2.33 because it's on the left-hand side. Okay, and so we are looking at a rejection region of Z is greater than negative 2.33. Now, if you were able to just look at the alpha and the p-value and know whether or not you should reject based on that, then you would not have to do most of step 4. But since we're just learning, we're going to go ahead and do that, and we're going to do the z statistic later. So step 5, what are the assumptions that I'm making? Let's look back. Did it say anything about random, the mean number based on the summary statistics? Doesn't say it was random, so we're going to have to assume it's random. A random sample. We don't know, and then our n is greater than or equal 30. That we did know, and then S estimates sigma, and it does say to use the S as given above. So then our actual calculations, and remember this is the point where you would actually do your study, and so we did our study and we came up with an X bar equals 19.3 and S is 11.9 and N equals, I think it's 46. 46. So we want to calculate our z statistic for this one. So it's going to be 19.3 minus our mu naught, which is 20, over 11.9 divided by the square root of 46. And when we calculate that out, I got negative 0.4. Okay? So we get negative 0.4, and if I draw that now, I'm okay with you putting these all on the same picture if that's making sense to you. But if you're still having a little bit of difficulty, you can go ahead and do it on a separate picture. No problem at all. I have a negative 0.4, so that's somewhere right here, and it's a z-score. So we're really looking at all of this area right here. And I can tell right now just by drawing that in, it's probably fail to reject, because that's really close to the mean, and so I think it's going to actually pass our tests. So that's my conclusion just based on that picture. But let's take a look at the rest of what we would need to do here. So our rejection region says that if z is greater than negative 2.33, then we'll reject, and it is not, so we'll reject for that reason. So if we're looking at just z-scores, then negative 0.4 is not less than negative 2.33, so we're going to fail to reject. Now, say you were trying to do this just using p-values, you didn't have your z-statistics, then what you would need to do, because we do need to find a p-value for this anyway, is we know this is negative 0.4, so we're going to look that up on our z-scores chart. 0.40, and it's going to give us 0.1554, and that is this area here, 0.1554, and so this big area here is going to be 0.5 minus 0.1554. Calculate that real quick, 0.5 minus 0.1554, and I get 0.3446. So my p-value is 0.3446. Wow, that's way bigger than the alpha of 0.01. And so because p-value is larger than alpha equals 0.01, we will fail to reject. And that's our p-value analysis. So if we're just looking at p-value and alpha. Okay, so this is my two conclusions for step 7, and then I would want to write these very nicely. We'll say there's insufficient evidence to reject H0 that the mean number of latex gloves used per week by hospital employees is 20. So, and then we want to say at a 0.01 significance level. Now, I think I've missed a couple of questions, so I've done my entire, this is my conclusion here, is probably more accurate. My calculations are above. So my conclusion, there's insufficient evidence to reject H0, and so we're unable to say that our mean is different than 20, less than, or whichever way, but So we wanted to, part A says compute the p-value. So we did compute a p-value, and it is right here. So this is the answer for part A. So we might just want to box that and label it just so that I can find that, but I am looking for the 7-step process anytime you can possibly use it. And then one more question, we might need the other page. Compare the p-value with 0.01 and make the appropriate conclusion. And so for that part, I just want to point out to you that that part B is looking for, well, it's looking for two things. It's looking for this whole piece here. This is part B. And it is not looking for an analysis of the z-scores and the rejection region. So that part is nice to put on here because it helps us verify that we did the p-value and the alpha analysis correctly, but it is not what's being asked for. What's being asked for is look at the p-value and the alpha and tell us what you're going to do and then draw your conclusion. Okay? And so remember that we always choose our alpha before we calculate our statistics, because we don't want to be led astray by the values that we get in our statistics. And then remember that alpha equals 0.15 is too high to reject H0. We just won't use it that high. And we talked about that in class today, but I just wanted to make sure you heard it again. So alpha equals 0.15 is too high to reject H0. For any study that you ever see, if they're saying it's significant at the 0.15 level, you're going, oh, no, bad study, your results aren't as significant as you think.